Hello, madam. My name is K. Harshavardhan. I am from CSMA section. Now, I am discussing about the topic decision trees and its structures. In this topic, we are going to know about the what are decision trees and structure of the decision trees, introduction to decision trees, and the advantages and their disadvantages and their algorithms. Now, we are going to the first topic, introduction to the decision trees. Decision trees are a popular machine learning algorithm used for classification and regression tasks. Here, we mostly use it for the classification task only. They model decisions and their possible consequences as a tree-like structure. Means here we will take the decisions in a tree manner, means tree-like structure. If we, I will say one thing, artificial intelligence is based upon the human intelligence. If human will take the own decisions, then we have to insert the decision making in AI also. So by using these decision trees, we will make them to decide by themselves. So here we can see that they model decisions and their possible consequences as a tree-like structure. This method is intuitive and easy to visualize and making it accessible for both technical and non-technical audiences. If we can see the example here is a person fit. Here we are checking that the person is a fit or not. Age less than 30. Mostly fit, unfit will be says before 30, after 30. So we will take age less than 30. If he is the age less than 30, then it will goes to the yes. If he is not less than 30, then it will goes to the no. After going to the yes, it will ask again here again decision node. It's a lot of pictures means asking the question. It's a lot of pizzas. If we eat lots of pizzas, we know it is junk food, so we will be not unfit. It's a lot of pizzas. Yes, so we are unfit. If we doesn't eat lot of pizzas, no, then we are fit. Here, going through this no option means no decision node. Here, exercises in the morning. If we the age is over to 30 means he doesn't eat the pizzas, so we will change the decision exercises in the morning. So we will ask the question exercise in the morning. If he does the exercise in the morning, then it will goes to yes. If he doesn't, it will goes to no. If he does the exercise in the morning, then it will goes to yes. He will be fit. If he doesn't does the exercise in the morning, then it will be no. He is unfit. Now we are seeing the structure of decision trees. A decision tree consists of nodes, branches, and leaves. As we can see the previous slide, there we can see the example. This person is a unfit or not fit. Means there we can see the root node and decision nodes and leaf nodes. Each internal node represents a feature or attribute, while branches represent decisions or outcomes. Means here each internal node represents some future, means some decision or some conditions. Like first we can see that the decision like eating pizzas or not, or exercise doing daily or not, like that. While branches represent decisions or outcomes, the branches will represent the decisions. And that below if it will satisfy the yes, then it will give the leaf node means outcome, or not it will give the decision node means decisions. Leaf nodes signify the final output or class label in the decision making process. Leaf nodes will signify the final output in decision making, means it will give the decision by through this tree. And we can see the structure. Here we can see the root node. If it will satisfy the yes, then we will go to the decision node. Or if it doesn't satisfy, and again we will go to the decision node. These two are called as branches. In decision node, it will satisfy, then it will go to the leaf node. If it doesn't satisfy, it again goes to decision node, and then again goes to yes or no or leaf node or decision node. Like this, the decision tree will take until we will get the outcome. Now we are discussing about the how decision trees works. In previous slides, we discussed about the structure of the decision trees and the introduction to decision trees. But now we are discussing about how the decision trees works. Firstly, the algorithm splits the data set into subsets based on the most significant features. Means it will divide the data set into different decisions to decide to take the decisions. This process continues recursively. Recursively means continuously until a stopping criterion is met. Stopping criterion means it's an algorithm to find the formula whether when to stop means the iteration when to stop, such as when it comes the maximum depth or minimum samples means minimum value or minimum feasible solution or maximum feasible solution per leaf. The result is a model that can predict outcomes based on the learned structure from the training data. We know that the due to this decision trees, we can predict the outcomes based on the training data. Now we can see the again another example, salary decision tree. Salary is between $50,000 and $80,000. If the salary is contains between $50,000 and $80,000, then it will be go to yes. And we can see that the here another decision node is there. Office near to home. If the office is near to home, it will be easy to him. So it will go to S and it will check the another decision. Provides cab facility. If it will provide cab facility, we will decide that we will decide means we will accept the offer or else we will decline the offer. If office is not near to the home, we will decline the offer. Or else salary is not between the 50,000 to 80,000. He will predict the means he will expecting the more salary or less salary. He will decline the offer. Now we are discussing about the another slight advantage of the decision trees. We know that the how decision trees works and how the structure of the decision trees are there and introduction to decision trees. But now we are seeing the advantage of the decision trees. Decision trees are easy to interpret and visualize, aiding in understanding the decision making process. So we have the one problem after intermediate which course we have to take means students will suffer. So here the decision trees will help them to how to take decisions. Means it will easy to interpret and it will give easy understanding lecture means in understanding way the decision making process. They can handle both numerical and categorical data without needing extensive pre-processing. And decision trees are not non-parametric, meaning they do not assume any underlying data distribution. And here we can see another example, color equals to red. If color equals to red satisfies, then we will go to another decision, model greater than or equal to 2010. If it will satisfies, we will go to yes, means he will buy. In no, there is a decision node. Means in no, if it doesn't satisfy, it will goes to decision node. Mileage less than 50,000 kilometers. If mileage is less than 50,000 kilometers, then it will goes to yes. Means he will buy that model means car. And if it doesn't satisfy, he will doesn't buy. Means he want that particular features. If color equal to red, no, he has another feature. If color equal to yellow, means he want to take yellow and red two colors. If red color is not available, then he will go to yellow. If color equal to yellow, then he will go to make equal to Ferrari, or else he will doesn't buy. If it is Ferrari, then he will conformly buy. If it doesn't satisfy, means it doesn't its name doesn't has a Ferrari, then he will doesn't buy. Now we are discussing about the disadvantages of the decision trees. Decision trees can be prone to overfitting, especially with complex data sets. Here, overfitting means decision trees can create overly complex trees that don't generalize data well. Means it will create sometimes it will create more decisions and it will be huge complex data structure. Means a tree structure, huge decision tree structure. So it will be very hard to decide whether the outcome is correct or wrong. So it will be the disadvantage of decision trees. They are sensitive to small changes in the data, which can result in a completely different street structure. When we create one tree structure, Then after we can modify the changes. Then it will be, then it will give different outcome, different outcome before them. So it is a disadvantage of decision tree. And also another one, decision trees may not perform well with imbalanced data sets, leading to biased predictions. Means here, biased predictions mean decision trees can be biased towards dominant classes in imbalanced data sets. Now we are discussing about the applications of the decision trees. Decision trees are used in various domains including finance, healthcare and marketing. Means here in these fields we have more judgments and decisions. So here we will mostly use the decision trees, and they are effective for customer segmentation and predicting customer behavior. In healthcare, decision trees assist in diagnosing diseases based on patient symptoms. We can predict that based on the symptoms, some diseases will attack, and through the same symptoms another disease also attacks. So we will decide whether the which disease has arrived to that patient, so through the this decision trees. Now we are discussing about the ensemble methods involving decision methods. Means which methods will use the decision trees. Ensemble methods like random forest and gradient boosting improve decision tree performance. Random forests combine multiple decision trees to enhance accuracy and reduce overfitting. We discussed previously. Overfitting means you complex tree structure. Means this random forest will make decision nodes combined, and means it will combine two decision trees, and it will reduce the overfitting. Means the complexity will be reduces. And gradient boosting builds trees sequentially, allowing each tree to correct errors made by previous ones. And conclusion, decision trees are fundamental tools in machine learning with several applications. Means this is main concept in the machine learning subject. Understanding their structure and functioning can aid in building effective predictive models. By addressing their limitation, decision trees can be powerful components of larger predictive systems. And thank you, madam, for listening my presentation. I hope you understand my presentation, and Jai Hind.